Welcome. This video is for based on iteration and calculus for A level P3. Some past paper questions based on this topic, iteration and calculus. The first one, the diagram shows the part of a curve y equals to x square cos 3x and x lies between 0 to pi by 6. The maximum point. Show that A satisfies. What do I mean? Maximum point. So first derivative should be equals to 0. So y equals to x square cos 3x. So this is going to be u and this is going to be v. You know uv whole prime equals to uv prime plus vu prime. So I'm going to find the dy by dx over there. So x square cos 3x derivative is minus sine 3x and 3x derivative is going to be 3 plus cos 3x as it is, x square derivative is going to be 2x. Now this should be equals to 0. So it becomes 2x cos 3x minus 3x square sine 3x equals to 0. So what do I get from there? 2x cos 3x equals to 3x square sine 3x. Then I cancel one x and x. So what am I going to get from there? I am going to get that 2 equals to 3x sine 3x divided by cos 3x. So it's going to be 2 upon 3x equals to tan 3x. So 3x equals to tan inverse 2 upon 3x. So x equals to 1 upon 3 tan inverse 2 upon 3x. This is going to be the answer. Now A satisfies for that 1 upon 3 tan inverse 2 upon 3. Next, use the iterative formula in the equation 1. So an plus 1 should be equals to 1 upon 3 tan inverse 2 upon 3an. Now initial value, we'll be taking it as pi by 6. You can take any value of x. So I'll take it pi by 6. So when n equals to 1, so I get a2 which is equals to 0.3017. N equals to 2, I get a3 which is 0.3820. Then I get a4 0.3502, a5 0.3624, a6 0.3576, a7 0.3595. Now when you see, when I round it off, this becomes 0.36, 0.36, 0.36. So therefore what I can write it as a5, a6, a7 all round to 0.36 to 2 decimal place. So a equals to 0.36. Coming to question number 2. In this question number 2, what is being asked? The diagram shows the curve y equals to square root of x cos x and x lies between 0 to 3 pi by 2. Then and its minimum point. This time it's going to be nothing but what? Minimum point. Minimum point means again derivative should be equals to 0. So dy by dx should be equals to root x derivative is 1 upon 2 root x times cos x. Next time root x as it is, cos x derivative is minus sin x. This should be equals to 0. So 1 upon 2 root x cos x minus root x sin x should be equals to 0. 1 upon 2 root x cos x equals to root x sin x. Then cos x equals to 2x sin x. What I have done it out? Root x times root x is nothing but x2x sin x. Then what does that becomes now? 1 upon 2x equals to sin x upon cos x. So tan x equals to 1 upon 2x. So tan A equals to 1 upon 2a. That's what has been asked us to prove. Now this is the iterative formula. Then use the initial value as 3. So a1 is going to be nothing but what? 3. a2 is going to be 3.3067. a3 3.2917. a4 3.2923 and A5 3.2923. So I get our A5 value also the same. Now we can see that all are converging to 3.29, 3.29, 3.29 and 3.29. So what am I going to write it out? I'm going to write it as A3, A4 and A5 all round to 3.29 to 2 decimal place. So x equals to 3.29. Coming to question number 3, the maximum point. Again, the maximum point is been given. So y equals to tan inverse of x upon root x. So this is going to be u and this is going to be v. U upon v whole prime will be equals to v u prime minus u v prime divided by v square. So what do I get it out? Dy by dx equals to square root of x. Tan inverse of x derivative is 1 upon 1 plus x square minus tan inverse of x root x derivative is 1 upon 2 root x divided by root x whole square is going to be x. This should be equals to 0. So square root of 1 plus x square minus tan inverse of x divided by 2 square root of x by x should be equals to 0. So square root of 1 x divided by 1 plus x square minus tan inverse of x upon 2 root x should be equals to 0. So tan inverse of x upon 2 root x equals to root x upon 1 plus x square. So do the cross multiplication. So what am I left over with? Tan inverse of x equals to 2x upon 1 plus x square. X equals to tan of 2x upon 1 plus x square. I think that is only been asked. From here we get it out. A equals to tan 2a by 1 plus a square. Tan 2a upon 1 plus a square. Verify by calculation. It lies between 1.3 and 1.5. So we need to set equals to 0. So what does that becomes? It becomes tan of 2a upon 1 plus a square minus a should be equals to 0. So a equals to 1.3, or this is f of a. Then it becomes tan of 2 times 1.3 by 1 plus 1.3 square minus 1.3, which is 0.148. Then a equals to 1.5, tan of 2 times 1.5 by 1 plus 1.5 square minus 1.5 minus 0.178. So given there's a sign change between x equals to 1.3 and x equals to 1.5, there is a root between these two values. That's going to be the answer. Now I'm going to do the iteration. So an plus 1 equals to tan of 2an by 1 plus an square. So a1 equals to 1.3000, a2 equals to 1.4484, a3 equals to 1.3552, a4 equals to 1.4148, a5 equals to 1.3769, a6 equals to 1.4012, a7 equals to 1.3857, then a8 equals to 1.3956, a9 equals to 1.3893, a10 equals to 1.3933. We can see that 1.39, 1.39, 1.39 and 1.39. So we can write A8, A9, A10 all round to 1.39 to 2 decimal place. So x equals to 1.39. Question number 4. The curve with an equation has a stationary point x equals to p where p is greater than 0. Show that p equals to. So y equals to x cube upon e power x minus 1. So what will be dy by dx? E power x minus 1 times 3x square minus x cube times e power x upon e power x minus 1 whole square. Now dy by dx equals to 0 at x equals to p. So it becomes 3p square e power p minus 1 minus p cube e power p by e power p minus 1 whole square equals to 0. So it becomes 3p square e power p minus 1 minus p cube e power p is going to be 0. 3p square e power p minus 1 equals to p cube e power p. So I will be getting it out. 3 e power p minus 1 equals to p e power p. P e power p equals to 3 times e power p minus 1. P equals to 3 e power p minus 3 by e power p. P equals to 3 e power p upon e power p minus 3 upon e power p. So p equals to 3 minus 3 e power minus p. So that's going to be the answer when I take 3 common, 1 minus e power minus p. Show that it lies between 2.5 and this one. So f of p equals to p minus 3 times 1 minus e power minus p whole 0. That p equals to 2.5. We'll be getting 2.5 minus 2.5 minus 3 times 1 minus e power minus 2.5, which is minus 0.254. Then p equals to 3. 3 minus 3 times 1 minus e power minus 3, which is 0.149. So sign change. Sign change between 2.5 and 3. 2.5 and 3 shows there is a root between x equals to 2.5 and x equals to 3. Now I'm going to do the iteration. So it's going to be pn plus 1 equals to 3 times 1 minus e per pn. So p1 equals to 2.500, p2 equals to 2.7537, p3 equals to 2.8089, p4 equals to 2.8192, p5 equals to 2.8210, and p6 equals to 2.8214. So we have p4, p5 and p6 all round to 2.82 to 2 decimal place. So p equals to 2.82. Now question number 5. F of x equals to this been given. Verify that by calculation the root lies between 1 and this one. So first of all, what am I going to do? X equals to f of x. So x equals to e power 2x plus 1 divided by e power 2x minus 1. So what does f of x will become? X minus x times e power 2x minus 1 minus e power 2x plus 1. This is going to be nothing but what? F of x. Now I am going to try it out. F of 1. F of 1 will become 1 times e power 2 minus 1 minus e power 2 plus 1, which is going to be nothing but what? Negative 2. F of 1.5. 1.5 times e power 2 times 1.5 minus 1 minus e power 2 times 1.5 plus 1, which is going to be 7.543. So again, sign change between 1 and 1.5 shows there is a root between x equals to 1 and x equals to 1.5. Now we need to do the iteration. So an plus 1 equals to e power 2an plus 1 divided by e power 2an minus 1. So a1 equals to 1.0000, a2 equals to 1.3130, a3 equals to 1.1560, a4 equals to 1.2199, a5 equals to 1.1910, a6 equals to 1.2035, a7 equals to 1.1980, a8 equals to 1.2004. So you can see that this is 1.20, 1.20, 1.20. So therefore a6, a7 and a8 all round to 1.20 to 2 decimal place. So a equals to 1.20. Hence find f prime x. For the exact value, f of minus f prime x equals to minus 8. So we have f of x equals to e power 2x plus 1 upon e power 2x minus 1. This is u, this is v. uv upon whole prime equals to v times u prime minus u times v prime by v square. So what does f prime x will become? 2e to the power of 2x times e power 2x minus 1 minus 2e power 2x times e power 2x plus 1 divided by e power 2x minus 1 whole square. Now f prime x equals to negative 8. So 2e power 2x times e power 2x minus 1 minus 2e power 2x times e power 2x plus 1 divided by e power 2x minus 1 whole square equals to negative 8. So 2e power 2x common, e power 2x minus 1 minus e power 2x minus 1 equals to negative 8 times e power 2x minus 1 whole square. E power 2x with power 2x gets cancels, minus 4 e power 2x equals to minus 8 times e power 4x minus 2 e power 2x plus 1. So minus 4 e power 2x equals to minus 8 e power 2x plus 16 e power 2x minus 8. So 8 e power 4x minus 20 e power 2x plus 8 equals to 0. So divide by 4, 4 times 2, 4 times 5, 4 times 2. So I will be getting it as 2 e power 2x whole square minus 5 e power 2x plus 2 equals to 0. So when I factorize it out, it becomes 2 e power 2x minus 1 times e power 2x minus 2 should be equals to 0. 2 e power 2x minus 1 equals to 0. E power 2x minus 2 equals to 0. E power 2x equals to 1 upon 2 or 2. Ln e power 2x equals to ln 2 power minus 1. 2x equals to negative 1. X equals to negative 1 by 2. Ln e power 2x equals to ln 2. 2x equals to ln 2. X equals to 1 upon 2 ln 2. So here we know that x is a positive number. X is greater than 0. So therefore, what am I going to do that? I am going to reject this answer. Answer is only 1 upon 2 ln 2. Next question number 6. So integration by parts. Integral 1 to a x to the power of 1 upon 2 negative 1 upon 2 ln x dx. So this is going to be the first function. This is second function. I use the acronym ILATE. I have logarithmic and algebraic. So I do the first function times integral of the second function minus integral of derivative of the first function and carry forward this x power 1 upon 2 1 upon 2 dx. Then it becomes 2x power 1 upon 2 ln x minus 2 integral x power negative 1 upon 2 negative 1 upon 2 dx. So it becomes 2x power 1 upon 2 ln x minus 2x power 1 upon 2 upon 1 upon 2, and try to write the limits 1 to a. Total the limits will become 1 to a. So what does that becomes now? 2a power 1 upon 2 ln a minus 4a power 1 upon 2 minus 0 minus 4. So 2 square root a ln a minus 4 square root a plus 4 equals to, how much is that? 6. So 2 square root a ln a minus 4 root a equals to 2. 2 square root ln a equals to 2 plus 4 root a. So square root ln a equals to 1 plus 2 root a. Ln a equals to 1 upon root a plus 2. So a equals to e to the power of 1 upon root a plus 2. That's going to be the answer. Verify by calculation, it lies between 9 and this one. So first of all, find f of a, which is a minus e to the power of 1 upon root a plus 2. So f of 9, which is 9 minus e to the power of 1 upon root 9 plus 2, which is going to be minus 1.312. F of 11, 11 minus e to the power of 1 upon root 11 plus 2, so which is 1.011. So again, sign change and write entire all the reason. Use the iterative formula. So I'll be getting it out, a n plus 1 equals to e to the power of 1 upon root a n plus 2. So a1 equals to 9.000, a2 equals to 10.3123, a3 equals to 10.0886, a4 equals to 10.1233, a5 equals to 10.1178, a6 equals to 10.1187. Now this is 10.12, 10.12 and 10.12. So a4, a5 and a6 all round to 10.12 to 2 decimal place. So x equals to 10.12. This is the part 1 video of this iteration and calculation. See you in the next part. See you in the next video. Bye.